All right, this is how to find the derivative of an equation using the definition of a derivative. And it is a pretty complicated situation, but there are lots of tricks that you can use to figure out how to do it without needing this equation. But we're going to start out trying to learn it with. So first of all, the equation for the derivative, using the definition of the derivative, is the limit as h approaches 0 of f of x plus h minus f of x divided by h. What exactly does that mean? Well, you're going to take every x in this equation, you're going to add plus h to it, subtracted by this equation divided by h. Now this one, because it's squared, it's not going to be x squared plus h squared, it's actually going to be x plus h as a whole with a square on the outside. So it's going to look a little something like this. 6 x plus h squared plus 5 x plus h, put this whole thing in parentheses, minus 6x squared plus 5x. All divided by h. And yes, that's very cricket. Now the next thing we want to do is distribute in the 6x plus h and the 5x plus h. But remember, because x plus h squared is squared, it is x plus h multiplied by x plus h. So we're going to use the FOIL method. First, outside, inside, last. FOIL. So we're going to do first, we get x squared, outside, xh, inside, another xh, and last is h squared. So we can simplify that to x squared plus 2xh plus h squared. And that's going to be the same for all of our x plus h's, or at least x plus h squared. It'll always look like that. So now we're going to distribute into 6, and we're going to have 6x squared plus 12xh plus 6h squared plus 5x plus 5h minus 6x squared and minus 5x. Remember, this negative symbol here is going to be distributed into both of these. They're both going to become negative. Now we divide it all over h. And that looks giant, doesn't it? But we can make it a little bit smaller. You see this? That's 6x squared here, and this 6x squared. That's a positive and a negative. So we can cancel those out because they make 0. Same thing with this 5x and this 5x. Positive and negative make 0. We cancel those out too. Now all we're left with is 12x plus h plus 6h squared plus 5h. Since all of these have an h in it, we can go ahead and cancel the h with the h that's in the denominator. And now we have 12x plus 6h plus 5. As we recall from earlier, this is the limit as h approaches 0. Therefore, we can plug 0 in for h and get 6 times 0 equals 0, so we can remove that from the equation as well. And now our final answer, the derivative of 6x squared plus 5x, is 12x plus 5. I know, that feels like a whole lot of work to get there. So I also have a much simpler way to figure this out. We'll just remove this really quick. This is something called the power rule. So it's basically f of x to the power of c, the derivative of x to the power of c, is c times x to the power of c minus 1. Now what does that mean? We're going to take that power, and we're going to multiply it down to the front coefficient, and we're going to subtract 1 from this. So we're going to get 2 times 6x, 2 minus 1, which gives us 12x, which is the first part of that derivative that we found, 12x plus 5. And this bottom here, it's going to be 5 times 1, because that's just x to the power of 1. X, 1 minus 1, x to the 0 is just 1. So we get